name is Michele. I work in Univ of Surrey, and I agree to support this tutorial. I'm not an expert in Galileo board, not Arduino. I have experience in other platform, and in terms of development, I have experience in the rest in Internet of Things. So I will try to give some example on how to integrate the Galileo board, that's quite handy platform, into the Internet of Things existing platform. So I just want to acknowledge two projects that allow me to be here. One is Societal. It's a project about empowering citizens to create service for their smart city by contributing data and resource to the service, not only consuming the service. And this open a lot of challenge in terms of privacy and security aspect you need to deal when you share your data. So, and this is one of the topics that Societal touch in deep in this project. And the other is IoT Lab. Societal was a project that we wrote with Alex, then Alex left, so it was one of his idea. And the IoT Lab is a project coordinated by Sebastian, that is here together with us, try to play with this Galileo board. And the main concept of IoT Lab is how to extend existing Internet of Things by crowdsourcing resource and data from other device. Again, IoT Lab, we are focusing now mainly on a mobile phone, engaging with the user participant, but also this can be a way for you, if you have your own Galileo board, you want to contribute data to the Internet of Things, you can do with this. So why then we are talking about Galileo and Internet of Things? Because Galileo seems to be very simple to use, at least in some aspects, so it's made for developer and practitioner. And we think in these two projects that the Internet of Things are made by people, by citizen, by user, not by someone that collect the data and gives you the data like a big enterprise like Google or whatever. So we want that people contribute to Internet of Things. So they can do with this kind of platform that are easy to use and up and running very quickly. So IoT Lab aim to create a community of crowdsourcing data to enhance the Internet of Things, and Societal thinks that sharing data while protecting your privacy, introducing concepts like circle of trust, may help the growth of Internet of Things and give control to the Internet of Things to user, not to enterprise. So I think that you are more or less familiar with Internet of Things. Is the main topic that we will discuss in the during the summer school. So Internet of Things, basically you have things that are connected to the internet, either directly or most of the time through a gateway. There is now a lot of interest in creating this sort of universal gateway that allow you to connect every single device, things with different protocol in a transparent way, so you don't need to worry about which protocol you are going to use. The gateway does the job, provide the abstraction layer that you need for integrating all the devices. Then you have a network infrastructure that allows to put things geographically distributed in a way that are all connected. And then you have cloud infrastructure that allow you to retrieve data or manipulate data and extract new knowledge. Examples are many, like example in the transportation, smart transport, smart city. There are many applications for smart energy, to save energy, to predict energy consumption, and schedule appliances based on this. Your home, this kind of stuff, you are all of them familiar with Nest and similar. And many applications in e-health environment to monitor patient, to monitor health condition of people. So I think you will see something more detailed during the summer school. So first of all, you have the platform now. You have the possibility to sense the environment with the platform, to do also some actuation, and you want to contribute to the Internet of Things with what you are sensing. So there are different platforms. One is Xively. I don't know if you ever heard about Xively. So Xively had a long history. Was first Pachube, then becomes Cosmos, yeah, and then now it's Xively. So the main idea of Xively is to create a place where the data can be easily stored and then accessed from external applications. So Xively provides storage as a service, so where you store the data and then you have some other simple way to access the data and build your own application. So the philosophy of Xively is to not to worry about where are the data, how to push the data, but just worry about how cool your application will look like using this data. So Xively has this, I can go quick and skip this one. So basically there is a hierarchy in the way you exploit that you provide the data in Xively. So you have a data stream that is made by different data points. So data points can be coming from one sensor or many sensors. And then you have a feed that allow you to retrieve this data. And then every feed is associated to a device. So you have your own device that can provide different feed. Pretty simple. So you can have different way to interact with Xively. You can write a single data point to a single data stream, or you can write a single data point to multiple data stream, multiple data point to single data stream, and multiple data point to multiple data stream. So you can create your own data set and decide how broad this data set and which kind of feature this data set expose. This is just an example of how you push data. So you can create, okay, you have the basic get and post, and you can put data, post data with put. So you have usually this JSON syntax. You don't need to be familiar with this now, so you will study later. But you know that basically you have a set of API, REST API that Xively provides. And using this REST API, this syntax, you can easily push the data into your device, your storage device in Xively. So it's just syntax that you need to, I'm not going too much into detail of this because it's just documentation that you can read. Then you have get, and you can access the data from your device, different capability. So you can decide the time frame for your data. You can provide just the starting point, you can provide the end point, you can provide both starting and end, you can provide the start and the duration for the your query. And the timestamp are formatted in ISO 8601. Okay, so these are very quick concepts about Xively. As I said, Xively is a service that allows you to store data. So now we can try to run an experiment that allows you to do this and use your own, create your own data set in Xively. So this is the main idea. So we can, I assume that everyone is working on Wi-Fi now. So you can open the sketch example that are provided in your IDE and open the Wi-Fi Pachube client. You should have that one. So I don't know what is the situation.
Hello. So if you can just go to examples, Wi-Fi,
yeah.
and Wi-Fi Pachube client, IDE, and open the file.
Is everyone there? There is not much to do now. Okay, so if you want to create, okay, this is messed. A Xively account, go to xively.com. Is everyone there? You can create an account for free if you are a developer, you don't want to exploit the data to build and sell your application, you can create an account for free in Xively. So what we are doing now is exploiting some tools that are already existing, some platforms that are already existing to do this Internet of Things concept. In future, I hope you will, in the maybe next or in 2 summer school, if you are still here, we will introduce the tool that the project that I mentioned before we create and will allow you to do this kind of combination of data. So far, there are few platforms that are advanced but not providing what we want to provide, but are a good example to start to play with and to create your own Internet of Things data set. So go to Xively, create an account, then on the Develop tab, press Add Device, and you can add a device. You can call whatever you want, Galileo. So maybe I should try to have a board up and running here as well. There are no sockets. Anyway.
If anyone has any issues with connecting again to Wi-Fi,
you can do this from, yeah, if you have connected the same network or the other network you are connected. I would suggest to have a private device. Okay, have you done this? I create mine, so okay, this was pretty simple, so I think everyone is there. So this is so if you have created a device, now we create a channel. That is where the data will go. The data that you will push will go. It can be, as I said again, it's a data stream, can be a data stream made by one multi-point, multiple point or different data stream. So we add the channel. You can call whatever you want, sensor 1 as suggested. You can ignore the other information. Okay, you will see on this side a key that is used to authenticate the device. So when you want to fetch with your REST API, do a GET, you will have to provide a key that allow you to be authenticate to access this device, and you can recognize the feed that is provided by this sensor using this key for the feed. Okay, do you have the device? So these are what I just said. Is everyone create his own device and channel, or is having some problem to do this? No? Good. Okay, so now it's time to open the sketch. I think you opened already. So I think you have these two macro. So one is the API key, what I told you, allow you to authenticate for the data stream. And the other is the feed ID, that is what allow you to, among all the data stream that you have in your device, to identify the one that you want to use to fetch the data. So you can open this and do this change, because of course the example was made for a specific device. So you have your own device now, and you have to change this.
This is the last thing I can try, sorry.
Okay, so was for example Wi-Fi Pachube client. Yeah, maybe to plug the device. Thank you. Yeah, you can unplug, yes. It's that's enough power. Thank you.
No, you can plug it in.
The board as well, but I will take mine, because this one I don't know from where it comes. So where are you? Have you created the device in Xively at the channel? I think so. This was easy. Have you started to modify your sketch? So basically, as I said, what we are doing is personalizing the sketch for your device and channel. update these two lines. We don't need to deal with this exception now.
People struggling with the Wi-Fi connectivity. Yeah. Just I think something with the access point. It doesn't give any
code. Basically, what you are doing is connecting to the Wi-Fi,
yeah,
and then acquire the client, and then form the put request that I showed before, where you have the API key, and you have also the feed ID. You form this put that I show, and then you get the data, and using this you post this to the Xively, and Xively does the update. So basically what you are doing here in this send data method is basically what we have seen before. It's something like this. Okay, so this is the concept. And if you go on Xively and you have a look to, yeah, you should see this kind of. This is what you should see. So more or less data arriving. If you shortcut this one, you will see also that your voltage goes to 0. So you can play with this.
Okay. So we then move on to the.
So basically what you can do is pushing data to the cloud and get data from the cloud from Xively, forming on any other client. You can create any mobile application that follow this REST API, and you can get this data and for instance visualize this data somewhere else. So this is maybe mainly the concept of what I want you to show. You push the data, and then maybe don't know your project what will be about, but you can eventually take the data and show the data, and there is a bunch of documentation on Xively that will explain you how to create some client that get data from Xively. So it's something that you can do. So you can do something more advanced. You can plug your Groove kit and expose other data that comes from other sensor, not only from the sensor, the voltage sensor that is on the board already. And as I said, you can have a look to the API that summarizes more or less how the API should look like, with the feed ID, the API key, and how you form, if you want to push just one sample at a time, you want to push a stream of sample, or this kind of stuff. And then you can get also information about how you can create a simple JavaScript that visualizes on a web page the data that you receive, or this kind of stuff. Okay, so now without real demo, because I don't know if it's gonna work, might have the same problem, but on the slides these are tests, so you can run the same stuff that I run on the slides.
I would like to ask you, is it possible to run the assembly on your own server? Can you deploy it on your own servers?
No, I think it's a it's provided as a service, so you have to comply to their requirements. You run just on their platform. You have different way to protect your data. So with authentication and depending on the contact you're going to subscribe, you have exclusive access to the data. But yeah, you need to pay something. For the developer, the platform is provided for free. So I want to show now the integration with ParaInput. That is another social platform for creating Internet of Things, social Internet of Things. So the main concept of ParaInput is that is a platform that allows you to quickly connect smart things and different boards. They have already example for the Galileo board. They support the Galileo board, and in order to create your Internet of Things app. So because it's social, it puts together many different data sources, not only data coming from real sensor, real board, but data coming also from Twitter feed, Facebook post, and all this kind of stuff. So you can create a ParaInput account from this URL. I would suggest to use Facebook if you don't want to input and create a new account with username and password. The Twitter account seems not working. I had some problem to create an account by link my Twitter account. So basically what you can do if you run these slides is switching on and off a LED. When you receive some message that use hashtag ParaInput, so you can do hashtag ParaInput on or ParaInput off, in order to switch on and switch off remotely the LED. So you just use Twitter as a way to activate something on your Galileo board. So assuming that you are at home, this is not anymore an LED, but is controlling your heater or whatever you want to turn on and turn off. You just post something on Twitter and you get this done automatically. And ParaInput gives already all the tools that allow you to do this in a seamless way. So you don't need to code something because we did some change, but basically ParaInput cook for you the sketch that you need to upload and all this kind of stuff, give you this tool. So this is also where most of the tools for Internet of Things are going now. So this is what you need. You need a Twitter account to post the command. You need an LED that you have in your Grow, or you can replace with any other sensor just to show an actuation. And yes, create ParaInput account and connect the Grow LED to the Galileo board. So I don't know if you have tried this already. Alex said before that you have the different LED, different color. You can get just the connector for the LED, and remember the short leg goes to D1 and the long leg goes to 2+, so otherwise the LED doesn't work. And you can connect, in the kit I didn't show here, there is where you have to connect on the Arduino shield, the different connector. Then what you can do is, when you have the account, you need to create a device. You can call Galileo actuator or whatever. So, and you have where is my, yeah, you have the icon here that represents the Galileo. So you select this and you add this into your workspace. Then you can edit some parameter for this Galileo actuator that you're going to create, and put your Wi-Fi MAC address, not the Ethernet. The device will ask you for the Ethernet because it cooks something for the Ethernet. You do Wi-Fi and select DHCP and download the sketch. When you download the sketch, the sketch is cooked, as I said, for Ethernet. I don't know why they don't do for Wi-Fi, because maybe they know that there are many issues in configuring the Wi-Fi and make it work, so Ethernet works better. So you need to do these changes. Replace the include Ethernet with include Wi-Fi, replace the Ethernet client with the Wi-Fi client. Then if you, I don't know if Alex provided you in the memory stick or already the code for making the different Grove sensor or actuator working, but if you go on the GitHub, as is on the manual, they will explain you It's very easy. It's this analog read or digital.
Most probe sensors, they will work just with normal Arduino read write digital analog. So you don't have to have anything special for it.
Yeah.
Only like the LCD display as well as the servo motor requires like some special drivers that you use.
You need just to be sure to identify the right pin where you connect the device. And if you follow the example, there is pin number 3, and then you put on output because it's an LED, so you need to do some output on this device, not any input, not reading. And then you can just upload the sketch. You're ready to receive command. I don't have a screenshot here. If you want, I can show you how it looks like. If you get the device, you get your board connected, you can already start to send command to the pin remotely. So before going to Twitter actuation, you can do actuation from here. So for instance, in my case was pin number 3 that I mapped to the Arduino shield with the LED. You can send command from here. You can just decide I want to send high or low, so turn on or turn off. You can take this from this web UI, and then you post the data, and then you see the actuation on your Arduino board. If everything is fine, the Arduino board with the sketch, the Galileo board with the sketch is properly connected to para input, you can already debug doing this and see if everything works fine. So it's quite a nice environment that provides you already, for this specific platform, the tool to interact without major coding from your side. It's just, in this case, I was using the Wi-Fi, so this is just the only change that you have to do, and we were using the Grove kit instead of other sensor like the Assume you use, but it's easy to customize and use your own stuff. So if you go to the slide, you will be guided to this example and make it run. Okay, so when you have done this, what you do is this one is the actuator. Okay, this is your workspace. You have the actuator, it's something that you create first. Then you create your sensor. You can decide among a list. So you have here, as I show, there is a list of sensor, there is a list of actuator. So we select first the actuator that is Galileo board. Now the sensor will be Twitter. So you select the Twitter, and then you have to create the Twitter sensor. Okay. Okay, give authorization. I create another one. Basically, oops, sorry. You go and edit this. You decide from which account the request will come with this name. So, okay, this name is generated automatically. It doesn't work. It's not. If you use Twitter, anywhere in Twitter, there is a post with hashtag, the hashtag that you decide, and this command, this will be read and used to do the actuation. If you want this come only from you, you don't want that someone that can turn on and turn off either at your place, but it's only you, you can link this to your Twitter account if you have a Twitter account. You should have, because otherwise you cannot test. But if a friend of you, a colleague of you has, can post if you select this name, either the general Twitter or your Twitter account. Then the hashtag we said can be hashtag para input. So you need to write something like this, hashtag para input, and then the number of tweets that you want to examine until this stops to work is you can put 20 is the default, and the word to search is on and off. As I said, you can do actuation on and off. So you basically do all the configuration here, and then you have this has been done already for in my case. Okay, this is this one. Then what you do is connect. Okay, I've done already, but you can connect this sensor to your actuator. Okay, this is the result. Okay, if you go here, you say connect, and you say you have only one actuator, you can connect, and you select this one and you connect. The result is that you get this connection between a sensor, that is in this case not a real sensor, it's a Twitter post. You can get an actuator, that is your Galileo board, and then you have the connection. And what you do is, okay, here I have already, you just add one more mapping, okay? So every mapping gives you a rule between the sensor and actuator, okay? If you do add, you can just put the rule here. So the rule is simple JavaScript. Basically says whatever comes from, I was using my account in this case, from Michele Nati, and the word that I search is off, and I don't receive any Michele Nati.on, I turn off. And you can put the rule here, and the result of this rule can be configured in the way I explained before. You just take the pin that you need. It's pin number 3 in this example, and you configure the rule. So means that need to go low, turn off. In the other case, I have this one, if it's on, I publish on, the result will be high, turn on the LED, give high voltage to the device. And it's basically this is what, then you save the configuration. You go to your Twitter account and you start to post and see what's happened. Okay, this should work as well. I tested, so if you follow this and maybe there is something that is missing or doesn't work, let me know. But following this, you will be able to do this actuation. And then when you have got your Parainfo account, more or less this is the concept. You create sensor actuator and you can start to do things. As long as you are in this range of option, it's not that difficult because all the information required are clear and you don't need to code much. So, and yeah, this is more or less what Internet of Things will be for a user with not much experience in coding and just hack things to make it work and to create their own solution. So in this case, I wouldn't say that it's difficult to actuate remotely your home doing action that you do in everyday life. So you will see this is the result of what you will see. And yeah, if you want then to play, I would suggest to change the actuator or that you use from your Grove kit, and then you can modify the Twitter sensor configuration in order to accept. You can test that many can post from different account the command to turn on and turn off, or just you somehow defining some policy for the actuation of your device. So this can be helpful for some application you want to develop. So unfortunately it didn't work as expected, but yeah,